Hi everyone, welcome back to our video lecture on Introduction to Numerical Analysis. In the previous lecture, we were discussing about numerical integration and we have derived a general formula for integration. The formula is as follows. Integral from a to b f of x dx will be equal to nh times y naught plus n by 2 delta y naught plus n to n minus 3 divided by 12 delta square y naught and so on. Now let us put n equal to 1 in this general formula and integrate from x0 to x1. If you put n equal to 1, the other terms will become 0, that is only y0 and delta y0 will be there and n equal to 1. So h y0 1 by 2 delta y0. Delta y0 we know that it is y1 minus y0. Simplifying, we will get h by 2 is equal to y0 plus y1. Similarly, applying the same result for the subintervals x1, x2, x2, x3 and up to xn minus 1 xn, we will get the integrals as integral x0 to x1 f of x is equal to h by 2 y0 plus y1. Integral x1 to x2 f of x dx will be h by 2 y1 plus y2. And up to integral xn minus 1 xn f of x will be h by 2 yn minus 1 plus yn. The total integral will be the sum of these integrals. That is, if you integrate all these things, the integral from a to b f of x dx will be h by 2 y0 plus 2 times y1 plus y2 up to yn minus 1 plus yn. This rule is called trapezoidal rule. Now let us see how we can apply trapezoidal rule in a particular problem. The question is as follows. From the following table of values of x and y, we are supposed to obtain the area bounded by the curve and x-axis from x equal to 7.47 to 7.52. If you know the exact value of the function, this is a definite integral problem, but here we don't have the exact value of the function, but we have a data set. So let us apply trapezoidal rule here. The rule says that integral from a to b f of x dx equal to h by 2 y0 plus 2 times y1 plus y2 up to yn minus 1 plus yn. So in this particular case, a is 7.47, b is 7.52, h is 0.01 and y0, y1, y2, all these values are obtained from the table. So the total integral will be 0.0996. Now try these problems yourself.